Okay, so today we're talking about 1 over x and x cubed. We already talked about one of these yesterday, but I want to make sure that you're able to, by the end of the hour, graph them. Like if we move it or reflect it. We're not going to be doing stretches on these. We're just going to be moving them and flipping them, because stretches are a bit of a pain to do by hand. So this is without a calculator. Not that you can't ever have one, but on the test, you're going to have to do these without a calculator. So like if you need to multiply a couple numbers, that's different than using the graphing feature. We are going to have the test when we get this is on 3 parts, and one is a calculator's allowed and one is a calculator's not allowed. And then the third part is a multiple choice thing. I think calculators are maybe allowed on that part, but anyway, there's somewhere you can and somewhere you can't use a calc. So what if you had to graph this without a calc? Well, generally, do you know now that it looks like this? All right, we've looked at it enough times. Now, if you wanted to know what specific points you would be able to put on it, you just go back to the original function and say, if I stick in a 0, what do I get? 0. If I stick in a 1 and I cube it, what do I get? And if I stick in a 2 and I cube it, I get. And if I stick in a negative 1 and I cube it, I get negative 1. And negative 2 gives me negative 8. And those are the parent points then. The points that I have to graph to make it actually look perfect. All right, so 0, 0 is here. Over 1, up 1's there. Notice that's on almost every graph is 1, 1. And then over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. It's right there. And over 1 and down 1, and over 2 and down 1, 2, 3, 4, 5, 6, 7, 8. Besides, if you try to stretch these things, they get almost like look like straight lines pretty quick because they're already kind of stretched. So, all right. Now, this would move it. Which way? Left 2. Now, do I have to go through and do the whole thing over again? Well, to me, I already know it's over 1, up 1, over 2, up 2, 3, 4, 5, 6, 7, 8. I'm not going to remake a whole chart for this. You know what I mean? I just did it. So now, if I want to do it for this, I can take all these points. 1, 2, 3, 4, 5, 6, 7, 8. And I can take them all and move them all left 2. So I just go, okay, new points are going to be here, and here, and there, and there, and there, and then I connect those dots. Okay? That's fairly easy to do. Now, could I have made a chart like this and made up new numbers? It might have been almost as fast. I could have just gone, okay, if I stick in 0, what do I get? 0 plus 2 is 2. 2 cubed is 8. So 0 goes with 8. See, 0 goes with 8 right there. If I stick in 1, what do I get? Stick in a 1. 1 plus 2 is 3. 3 cubed is 27. So 1, I can't even possibly graph that on this because it's too big. If I stick in negative 1 goes in here. And I get 1. And 1 cubed is 1. So negative 1 goes with 1. And that's this one right here. So, etc. You could have just probably made an XY chart and made it go faster. But I want you to be able to do both. I want you to be able to make an XY chart like this and then get the points that way. But even more important, just look at it and say, okay, the normal one kind of looks like this. And now I'm going to say this one moves where? And what's this other thing? Which way flip? Up, down, or left, right? Ooh, a lot of people say left, right on that, and that's not right. It's up, down. Why is it not left, right? Because we need it in parentheses like this. I know that seems like it doesn't matter, but it does. All right, now a left-right flip and an up-down flip on this thing actually look the same, which is a little confusing, but generally speaking, anytime you're looking at this, that negative there is on the outside. So that is an up-down thing. Okay? All right, for that to be an inside thing, it would have to be like this. Then it'd be a left-right thing. Now, like I said, an up-down flip and a left-right flip on this particular shape happens to look the same. All right, so if I had to do this one, if I needed it to be right, I would probably go back to this and say stick in 0. And then I have 0 cubed and negative 0 is 0, plus 4 is 4. And then I'd stick in 1. And that would be negative 1 plus 4, which would be 3. And I would just make a list of points. Okay? All right, moving on. This one. This is really weird. I want you to see it on your calculator first. Would you please grab your graphing calculator and type in 1 divided by x. And I will get some more lights on in here. Okay, so 1 divided by x. Enter. Graph. Oh, I'm sorry, I had it cubed by accident. I didn't mean that. 1 divided by plain old x. There we go. There we go. I don't think, you're right, I needed to do it one more time. Stupid little power, I gotta get rid of it. Now delete. Yes, there we go. Okay. That is hard to see what's going on. So I practiced these zooms with you the other day. Hit zoom. And let's do a zoom in so we can see what's going on better. But as soon as I do that, it wants me to tell it, where should I zoom in, master? And you tell it, okay, I really like to zoom in right at the origin there. So get the little blinky dot thing or the little spider thing to be right at the origin or near it, and then hit enter. Now can you see it a little bit better? Maybe we're in too close. I don't know. That was... All right, so let's talk about why it is that way. Well, x, y. Let's pick some numbers and try it. Oh, crackly noise, driving me crazy. Stop that. Okay, if I stick in a 0 for x, this gets weird. What's 1 over 0? See, there's two things. There's 0 over 1, and that's one thing, and there's 1 over 0, and that's a different thing. One of these things is okay, one of them is an error. Which one's okay? Yep, this one's okay. But what we have is this one, and that's an error. It does not exist. If you think about it, if you have a cookie, and you divide it amongst 0 people, it doesn't make any sense. You can't figure out how to divide it. And you're selfish. Okay, good. So anyway, this one is 1 over 0, which I don't know what to write, so I'm going to write this. And I'll tell you what it means in a second. Would you please write this down on your notes? You're going to want this in your notes. It's your first exposure to an asymptote. I don't think you learned this last year. Did you? Okay. An asymptote is a line that you get super close to, but you never touch. Let's talk about how you could have that in the real world, where it gets closer and closer and closer to it, and it never touches it. Oh, very good, yeah. It's sort of like if you want to get out that door there, the door in the classroom. If I want to get out that door, would you agree that it's going to take me some time to get out that door? Some amount of time. I can't just instantaneously be outside the door, right? It takes some time. Well, in order to get from here to that door, I'm going to have to get halfway to the door first, right? So if I'm going to have to get halfway to the door, and that's going to take me some amount of time, right? Once I get there, it's the same problem. I have to get halfway to the door before I can get to the door, right? And that's going to take some amount of time, right? So it's called an infinite series. I'm going to have to keep on adding up the little half distances. And now I got to get halfway to the door again. And it's going to take me some amount of time, right? So isn't there always going to be a little bit more time needed? So in theory, if you take that to its ridiculous extreme, you can never get to the door. But you can. That's right. So are you saying I didn't go halfway? I had to go halfway, didn't I? And doesn't it take me some time to go halfway? So where's the flaw in the argument? But don't I have to get halfway first? I can skip over halfway? Is that what you're saying? Ah. Just jump over the halfway. Well, then I was at halfway. It was just on the way. Yeah, but okay, anyway. So let's talk about another example of getting really, really close, but you can never make it perfect. The air you're breathing right now. Do you think it's perfect? There's definitely some odor of hand cleaner right now. And there's all kinds of stuff in this air right now. And believe it or not, they say that we're all still breathing dinosaur farts too, because they have little tiny little particles up in the atmosphere that have been around since those days, and you could be breathing in a little bit of the last breath of Caesar. You could be breathing in a little bit of a dinosaur fart, and you could be breathing in a little bit of something that came out of a smokestack at some factory nearby. And you can be breathing all that in one breath, because think about all the little tiny molecules that you're breathing in with one breath. And all those molecules mixing together up in the air. So when you're breathing oxygen or air, you're not just getting oxygen, you're getting other stuff, but you're getting contaminants in there too. And you're always getting contaminants, like the food that you eat, those Wheaties that you made yourself for breakfast. You think that was all wheat in there? Nope. Because when they get the wheat, they also get little particles of dirt. I mean, the farmers aren't bringing in the wheat and it's all like cleaned and perfect. There's going to be a little bit of dirt in there. It's going to be a little bit of bugs in there. Yep. Almost nothing is going to be completely pure. How about water? The water you pour out of your tap, I think you're aware of this. There's little contaminants in there, right? As long as it's not too much, it's not going to hurt you. But there's little contaminants. It's never completely pure. All right, so there's the idea of an asymptote, is you can get close but never be perfect. If I had this bucket here and I wanted to have, if I had completely pure water and I poured it in there, poured in like a little bit, and then I put in 1 drop of poison, okay? There are different kinds of poison, but let's just say that it's some kind of liquid poison. Like, let's say alcohol. Alcohol is a poison. It is. And ingested in small enough amounts, it won't kill you. But in too great of an amount, it will kill you. So anyway, alcohol is a poison. If I put a little bit of alcohol in with the water, is the water pure anymore? Can I get it closer to pure? Yeah, by pouring in more pure water, right? And if I get it really, really close to pure, but it will ever be pure again? No, because it had a little bit of alcohol in it, which will mix in with everything, and so it will never be 100% pure. Same idea as an asymptote. You can get really, really close, but you'll never touch. So here are the parent points. If I stick in a 1, then I get 1 over 1, which is 1. So 1, 1 is one of my points. And if I stick in -1, then I have a -1 here, and my answer is -1. And that's another nice point. But all the rest of them are not nice points. If I stick in 2, all of a sudden I have 1/2. 2 goes with 1/2. So I go over 2 and up 1/2. Over 3 and up 1/3. See where I'm going with this? Over 4 and up 1/4. And it's going to get closer and closer and never touch that. And it's going to get closer and closer and never touch that. Because there's another asymptote there. Just a second. Wait. So then this gets closer and closer, never touch, and this gets closer and closer, never touch. If you made every single point and you graphed them, it would look like that. So there are 2 lines that gets closer and closer and never touches. There's a horizontal asymptote. Horizontal is like horizon, so this is the horizontal asymptote. And there's a vertical asymptote. All right, let's talk about that more in a minute. For right now, can you just picture what the parent one looked like? It was kind of like this. I'm talking about? If I wanted to move this thing, which way do you think it would move? Think of that as being an inside. Because remember, things in a fraction always have parentheses. 2, where? Up, down, left, right. Right 2. So the whole thing would move right 2. So I take this whole thing and I move it over right 2. It changes the asymptotes. The asymptote lines are still there. They're here now. They're at 2 and 0. Now, why is there an asymptote at 2? See, it's at 2. This is this line right here. It's at 2. Because if I put in a 2, see what happens? I get 1 over 0. And that's where you have a problem. All right, so let's look at another one. This one, can you just look for a second and tell me where would I have a problem on this graph? What would cause there to be a 0 in the denominator? If x was what? -3. If x is -3, I'm going to have a problem, and that's where I'm going to have an asymptote. Okay, so I'm going to go to x is -3. Here it is. And there is an asymptote right there. Can you picture that my graph is probably then going to look something like this, but I don't exactly know whether it's right there or whether it's shifted up or down, but it's got to be around that line. And see that -5 there? That -5 means down 5 from normal, right? There's normal. Down 5. All right. And there's an asymptote across here. Okay. Now, I know some of you are going to get overwhelmed with, oh, it's crazy, this asymptotes and things, and I don't get it. Well, you can always go back to your safety zone. Your safety zone is this way will always work with every problem. When you're asked to graph this on the test and you get lost in your asymptotes, so to speak, then you can always go like this, x and y, and pick any number you want and stick it in and see what happens. If I pick x is 1, I'd like you to figure out and make me a list now. X, Y, like this. For this part, grab your pencil, this is the part where you get actively involved, and I want you to make me a list of some points that would work. Stick in 1 for x to start with, and then after that, pick other numbers that are smallish numbers. One of the ones you definitely want to do is the asymptote. If you're stuck in a 1, do you get that you have 1/4, 1/4 minus 5? So what does that come out to be? Negative? Yep, -4 3/4. Now, I could pick any numbers I want, so maybe I should pick numbers that are going to work nice. Like x is 0 should be a fairly easy one to do. Then it just makes that 0, and so it's 1/3 minus 5. So that would be -4 and what? 2/3. What else would be easy to do? Okay, 2. 1/5 minus 5. -4 and 1/5 minus 5. 4/5. How about that asymptote line? -3 would cause that. And what do I put when it's 1/0? It doesn't even matter what the rest of the problem is. If you have an over 0, you're at asymptote. All right. How about a couple more numbers? -2. Stick in a -2 here. And then I get 1/1. Ooh, that's 1. 1 minus 5 is -4. So now if I graph these, you'll get an idea of where this thing should be without having to know all that stuff about asymptotes I was telling you before. 1 goes with -4 3/4. Go over to 1, go down to -1, 2, 3, 4, and 3/4 is like right there. 0 is over 0 and down -4 2/3. Man, it's hard to tell where that is, whether it's higher or lower. 2 goes with -4 4/5. That's lower. So it looks like it's kind of getting lower and lower. -3 goes with an asymptote. That helps. So now I know that I need to get points that are closer to this asymptote line so I can kind of see where it's going. -2. -2 goes with -4. Ah, it's going to go up like that. Can you start to see where this is headed? It's getting closer and closer to this line right here, and it's never going to touch it. And if I were to like freehand it from here, which would be fine, I'd go. And then, yeah, it's like a reflection. See this point right here? can you see that there'd be a point right there that would go with it? And then it would go like this. Okay, so could I find all those points by graphing them? Absolutely, I could. I could continue to just plug in points. I know that I need some more negative ones, so I might try like -4 and see what happens. -4 would give me 1/1 is 1, 1 minus 5 is -1 minus 5 is -6, yep. So -4, 1, 2, 3, 4 goes to -1, 2, 4, 5. Oh, that was that point right there. I could just keep on getting points like that if I wanted to. But now that I kind of know where those asymptote lines are, it'll be easier to graph. All right, so if I gave you 2 asymptote lines, and I said one asymptote goes here, one asymptote goes there, can you see how I just have to go like this? And then get closer and closer and never touch. Closer and closer, never touch. See what I mean? So once you know where the asymptote lines is, it's simple, right? That's what I'm going to teach you more tomorrow, is how to figure out where those asymptote lines are. But for right now, all I need you to know is a little XY chart. You can always make an XY chart. Stop with that, please. Okay. So, I guess, sensing that you guys are pretty much done paying attention, I think we should just get to your worksheet. So, here we go.